So now it is time for us to put all of this together. I will go ahead and say try catch. So this is going to be the main entrance point of our application. So anything happens, we want to catch the exceptions and log it or do something with it. In this case, I'm just going to say console write line, and I'm going to just log the message. I'm going to create a template here and say something like this. Sudoku puzzle cannot be solved because there was an error. And then I'm going to say ex message. So this is going to print out the message, the error message. Then I will just leave a comment saying in real world we would want to log this message. So essentially, if anything happens in here, which is us solving the puzzle, reading, doing everything basically. If anything happens, we just say Sudoku puzzle cannot be solved because there was an error. We just throw the error. It's going to bubble up and we're going to throw the error. So we're handling exceptions. And I say in real world we want to log this message because in real world we want to log it in a database or somewhere where we can come back to it. Now let's write the body. So Sudoku mapper, and we don't have access to it just yet, but I will import it, the workers. So Sudoku mapper equals new Sudoku mapper, Sudoku state manager equals new Sudoku state manager, Sudoku solver engine, Sudoku solver engine using strategies. Great. So we're basically initializing all these. And the engine actually takes in a Sudoku board manager, so this guy, and it also takes in a Sudoku mapper as dependencies, right? Remember that? So it takes them in, then Sudoku, so Sudoku file reader, and we're going to initialize that one as well. Doesn't take anything in. And Sudoku board displayer. So Sudoku board displayer. And that's, I think, it for all of the classes that we need. And now we're going to say console write line. And we're going to say, please enter the file name containing the Sudoku puzzle. So please enter the file name containing the Sudoku puzzle. So please enter the file name containing the Sudoku puzzle. Great. Var file name. I'm basically getting an input from a user. So I'm saying read line. And file name is going to be what they give me. And Sudoku board. So Sudoku board is equal to Sudoku. So Sudoku file reader dot read file, and we're going to pass in the file name. See how everything just kind of like clicks together? And everything we've written now helps us to write our main application. So then we say Sudoku board displayer. So Sudoku board displayer dot display the initial state, which is going to be, we're going to get a title, so initial state, and then we're going to say Sudoku board. There you go. Then we're going to say bool is Sudoku solved. And we're going to say Sudoku solver engine solve, and we're going to pass in the Sudoku board that we just read and converted into two-dimensional array. Then we're going to say Sudoku, so Sudoku board displayer, display that in the final stage after it has been solved. So, well, not here. We just say that, and then we say display, and the title will be final state, and we're going to pass in once again the Sudoku board. There you go. We're almost done. Write line, And in the right line, we're going to say the following. Is Sudoku solved? And we are going to make a use of the ternary operator. We're going to say the following. You have successfully solved this Sudoku puzzle if everything goes well. Otherwise, say, unfortunately, current algorithm or algorithms were not enough to solve the current Sudoku puzzle. There you go. So this is our application. Let's actually go over all the wordings. Please enter the file name containing the Sudoku puzzle. Initial state, final state. You have successfully solved this Sudoku puzzle. Unfortunately, current algorithms algorithms were not enough to solve the current Sudoku puzzle. Great. So as you see, this is just putting everything that we've written together. But we're missing one thing. If we go to Sudoku Solver Engine, right here, we don't have any strategies entered. So what we need to do is we need to say new simple strategy. We need to create that. Then we need to create the new naked pair strategy or naked pair strategy. And we need to pass in the Sudoku mapper because that's what they need. So now we have strategies. And whenever you have your strategies, you will include them in this list and the Sudoku will become a lot smarter, so you can evolve this program, and that's the beauty of it. And see how simple it is. The iSudoku strategy does not know what strategy it is, so you're literally running through strategies and just calling solve on it, and the solve just solves it itself based on the strategy that we have defined. But you do not know in here which strategy it is that's being called, right? You're just saying solve. And it's either going to be simple markup strategy or naked pair strategy or anything else for that matter. Any other strategy that you put in here that has to implement iSudoku strategy. And this is beautiful. Now let's actually go ahead and run this program. I will breakpoint right here so it doesn't close down. And as you already know, I have a couple of Sudoku samples here. So I will say open file in Explorer, bin, debug, and you see easy, evil, hard, medium. So I will go ahead and start with the easy. So I will say Sudoku easy.txt. And let's see. It says initial state, final state. You have successfully solved this Sudoku puzzle. Great. Let's actually go ahead and do the medium one. I will say Sudoku medium.txt. Great. Solved that as well. No problem so far. Let's do the hard one. See if it can handle it. Sudoku hard.txt. Once again, no problem. Went all the way to the finish. And then, let's see the evil one. Sudoku evil.txt. And for that one, we weren't able to solve it. See, these were the possibilities. So it wasn't able to, this one was singled out, a couple of them were singled out, but all these were just possibilities. So it says, unfortunately, current algorithm or algorithms were not enough to solve the current Sudoku puzzle. So this is when you would go back to the drawing board, figure out which strategy you want to write, and then go ahead and write the strategy, implement it from iSudoku strategy, and pop this in here. And that's going to make your Sudoku solver a lot stronger and smarter, and you will be able to solve much more complex Sudoku puzzles. And that's the beauty of polymorphism, beauty of dependency injection, and just beauty of writing clean code that you can extend and maintain easily. And when looking at it, you get this pleasure that you have written something that's both beautiful, efficient, and working. I think this is one of the best things about being a programmer, is when you can feel this feeling after you have completed a very difficult task, is feeling this pride for your work.